Hi everyone, it's Has, and today we are going to continue with the ANSYS tutorial. And the first one that I'm going to do is to take this block and slide it right here. And what I can do as well is to enter in the engineering data. So let's open it and let's see we have structural steel as a default material properties. We have everything we need for this simulation. So I don't need to create a new one. I can just consider it and let's close this and let's go to geometry. Let's right click and go to new space claim geometry. So today I'm not going to create or to design the geometry in new space claim, but I will just import it because I already have the geometry. I created my geometry on Katia and I just save it as a step file and I can just import it. And the way you do it, you go to file and then open and then you change the file here, the file type and step, and you can see your geometry is right here. And now the geometry is going to appear right here. But before, let's look at the tree. And if you look at the tree, you can see that it's part 1, part 2, part 3, and part 3. So part 3 and part 3, these are the knots. I mean, the same parts. That's why they have the exact same name. What we can do is to rename all of them, but it's better to do any modification that you want right here to do everything that you need in your geometry. And once the geometry is ready, you can just go and rename your parts and give the names that you want, and then you move on. But before you give the name, let's just look at the geometry. So we can see there is a little gap right here between the nuts and the plate surface. Let's correct it. And to do it is to go on the design tool and let's go to move. And then you come right here and you select it. But first you zoom it and then you be here. So I just selected it. What I can do is to slide the arrow like that and go to here. But there is another thing that is more simple is to come up here and click this tool up to, and you can just click the surface and automatically the knot just moved in the plate. And now let's look at right here. So there is a little gap right here as well. What you do is to click right here and then up to, and you click the edge, because that's the limit. So now everything is fine. Our geometry is ready, so we can give the name. Right click here, but before let's click on selects to be sure not to damage anything. So let's right click, rename plate. And the other one, this again is the bolt. This is bolt. And this, the part 3 is going to be nuts. So all of them are renamed nut because they are the same parts. Let's close the geometry because we already finished the geometry. And what we can do is to enter our model. Let's open it. So here is the model window. Let's right click and then zoom the fit. And now I have my geometry right here. So everything is fine. If you look at this, you can say, oh, maybe because you see yeah, I think everything is fine. So every part have its own color. The plate has its own color. I mean, let's click out body. So it's going to select all the body. If I click here, you can see this is first body, second, third, and fourth. So everything is fine. In geometry, everything is fine. I have my plate, bolt, not. What I would do is to create the connections, I mean the contacts, because on connection you can create a lot of things, and one of them are the contacts. But if you look at the tree, you can see there are some contacts that are already created. And it's not me who created them, but they are just automatic connection or automatic contacts. And you can see that the software did an amazing job, but it's not really what I want. But they are acceptable contacts, but it's not really what I want. And I also want to show you the way you create more effective contact. So let's just suppress all of them. So delete. What I will do first, let's go to connection and look at here, generate automatic connection or refresh. So I'm going to set it as no because I don't want every time that I open to have automatic connections, and I would have to suppress them every single time. So I don't need them. So let's right click and create our contact. So right click, insert manual contact origin. Let's create another one to another one, last one, 4 contacts. And what I will do is to go to the first one, and I'm going to set a contact from this nut and this surface. So let's click equal is going to be my target, and let's hide this, and then click right here and then contacts. You have contact and target. Usually the contact is the one that you move it to. It's pretty logical that the knot is the contact one because you bring it to come and how to say, to bond it with the other one. But it's not really bonded contact, it's frictional. And I'm going to change this to frictional, but I don't want to do it once one contact, I'm going to do it many times. So I just want to do it for one time, and you are going to see why it's more good. It's better not to set it right now, but to finish every contact and then start doing it. So the second one, let's do to the opposite side. Click target, and then you hide it. You click here, equal contacts, show all the bodies. So now you have 2 contacts. The other one, the next one is going to be the bolt and the plate. So what I'm going to do is to take this, and it's going to be contact, and then you hide this, and then you can, put this. Then you can see that you need to select the 2 faces. Equal is going to be target, and then the other ones, in the other side. But now you don't click the equal. You click the plus, because if you click the equal, the one that you already selected it here, they are going to be removed. So you click plus in order to add them. So now you have 4 faces here. So it's more good. And let's show all the bodies. And right now is the last one is going to be between the nuts and the bolts. So let's hide the bolts, and let's click the nuts faces, and then contact, and then you come up here. No, you click this, and then this plus contacts, and then you show all the bodies, and you take this. Why do I take the body one but not the face? Because if I take the face, I will have to click it 2 times here, and I don't want it. I just want to click it only 1 time. So equal target. Now everything is fine, but let's set them the type of the contacts that we want. So the type of the contact, the first contact is between this nut and the plate surface. So this is frictional, and then let's say 0.1, the coefficient. And the other one as well is going to be frictional, and the third one as well. So let's select all of them, and let's say frictional, and the coefficient, let's set it as 0.1. So, okay, let's go to the last one. The last one is going to be bonded, because I want the nuts to be bonded with the bolt. So I keep it as bonded, and everything is fine. But let's rename the 3 first contact as frictional contacts, because they are frictional, So now everything is fine about my contacts. What I would do is the mesh. Let's right click in the mesh and click generate mesh. And if you look at here, we can see we have pretty good mesh between the nuts and the bolts, but my plate is triangular, and we can see that the elements are very larger. So what I would do is to change here. Let's right click here and let's do method, and let's select the whole plate and add it, and let's change, because I have triangular elements, I want to have them as hex dominant, and now it's gonna be good. But what I would do is to put, small size, for example, 5 is fine, and I can right click here and do updates, and let's see what I'm gonna have. And we can see that we have a pretty good mesh right here. Probably right here, the mesh is not quite good, but it's fine, because what I want to see is really in the bolt and the nuts. But here, it don't really interest me that much. So we can keep it like that. So now everything is fine. We can go here and right click and go to fix supports. Fix supports is gonna be here, down. So now that I finished creating, so now after I created the fixed support, I can add a bolt pretension. So how to create a bolt pretension? It's pretty simple, not that simple, but the way you do it, you just right click in here and then insert, and then you go to bolt pretension. And then as we see that we have two faces right here, for example, we have this and this, so you can't select them too, because it's going to be the same thing, it's going to cause error. So you just select the two face. For example, you just only one face. So equal, so you just have this bolt pretension. That means it's going to slice this body, and then the elements are going to start coming that way. You can see the two arrows. So that means it's going to move these plates, or maybe the bolts, as well, and then comes to me right here. So this is the origin. If you want to change this origin, you can just come up coordinate system and then change the coordinates. But we can maybe do it later or in another video if you really want to know how to do it. So you come up here, because we didn't finish yet. You are going to add a load. If you know the millimeter, you can just come up here, adjustment, and put the millimeter. Let's say 0.2, for example, millimeter. We can change it later, but let's see. This is the bolt pretension, and we see the deformation. Is it going to be higher than this or lower than this? We don't know yet. We need to run it and see. But before, let's go back to the contacts. In the contacts, we can change the behavior. Why? Because right now we have program control. So the software will understand to manage it the way he can, but I don't think he will do a pretty good job. So we will set all of them as symmetrical. Why I'm putting it as symmetric? The reason I put it as symmetric, I can, let's say, all of these, I can suppress all of these messages. I don't want to see them. Let's suppress. Okay. So now here, behavior, I have symmetric. Why? Because with symmetric behavior, that means there will be low separation. Yeah, there will be low separation between the contacts. But the thing, that's more effective. But the thing is that that's very costly, computational costly. So yeah, you can just leave it as you want, but put all of them as symmetric, so it's going to be a really good job. So let's right click here and hit solve. And let's see. We can go on messages here, so we can see, let's go to solution information, and let's change the solver input into displacement convergence, so we can see the convergence of the displacement, till the criterion. We can also put the force convergence, so we can see the way it is, the force convergence. we can see it came to here. So now the simulation is already done. We can come out solution and right click, insert deformation, total, right click again and go to stress equivalent voltmeters. So let's right click and evaluate so we can see this is the stresses. But let's go to the deformation. Deformation, see the way it is. Maybe that's because we are on, let's say, symmetric, So we can see that it's not even higher than 0.2. But let's go to animation and see. If you see to animation, you can see the way it is. Let's go and exaggerate a little bit and let's see. Let's see. You can see the bolt here, it's getting moved. That's how it is. That's the pretension.